Welcome to this week's superhero simulation. This week we're going to look at Hulk Smash using Autodesk Simulation Mechanical. As always, feel free to reach out to me with any questions, james.herzing@autodesk.com, or follow me either place on Twitter. So what do we know about the Hulk other than that he is incredible? Well, his strength increases with his level of anger or change in emotion. He can leap very large distances, like around the world almost. High resistance to physical damage, extreme temperature, mind control, nuclear explosions, poisons, and all diseases. Yet he is green. I know some diseases that make things turn green, but whatever. Has a gland, oh this is a good one, that makes oxygenated perfluorocarbon emulsion. I guess that's a fancy way of saying he can breathe underwater. And also, when he's Bruce Banner, he's so smart that his intelligence can't be tested. That is pretty smart. So what actually matters for us? Well, none of that. All that really matters is that the Hulk is a big fatty. So like all of these superheroes I'm finding out, there are multiple versions. Gray Hulk, which I didn't know exists, is a 900-pound fatty. Green Hulk can get all the way up to 1,400 pounds, so that's what we're going to be looking at while he walks his way up some steel stairs. And also he leaves green footprints, because why wouldn't he leave green footprints? So here are our stairs inside of Fusion 360. You can see that I actually have gone ahead and did a split face command on the different stairs, 4 of the stairs, and then he's going to jump up and land on the top landing point. So simple command is going to allow us to simplify our model. So that's one of the big parts about simulation, right? Keeping things simple. So instead of modeling the Hulk, we can just model his footprints and use forces to represent all of his fat. So we're going to go ahead and open up our IGES file. And when we do that, we can see it here in Autodesk Simulation Mechanical. And we're going to go ahead and instead of doing a linear static stress analysis, we're going to define it as a mechanical event simulation. And start defining our loads and boundary conditions. So if I just go ahead and grab all of the surfaces that make up the Hulk's footprint, I can go to Setup and choose Force and define a magnitude of minus 1,400 pounds of force, and clearly that is in the Z direction. But also I'm going to check the box that says distribute magnitude across all the surfaces, so it's distributing across his foot. We're going to do the same thing here for his next footstep, adding a force and typing those values in, but this time we're going to change the load case or load curve number to 2. And so now let's go ahead and speed this up a little bit. Nobody wants to watch me do this over and over again. But we're going to do this for the other footprints and where he jumps and lands. And each one of these is going to get its own load case to define how it's acting over time. So it's basically going to be like him taking steps up and down the stair, up the stairs, and then jumping at the end and landing on that top stair. So next let's go ahead and choose to generate our mesh. And you can see our force arrows are now there. We can see a more refined mesh around where his feet are. And now all we really have to do is add some materials to these parts. And again, these are steel stairs. So if we right click and choose Edit, as always I'm going with A36. And now if we go in and edit our parameters, we can also define the number of time steps that we have. So let's go ahead and do that. And now we're defining each load curve. Again, speeding up so you don't have to see all of it. All I'm doing is saying what time the load is going to start being applied and what time it's going to end being applied. So here we go, apply, apply, apply. And into the results we go. Now I didn't show us setting up any of our boundary conditions, but all I did was add some fixed boundary conditions anywhere that the posts would be hitting the ground, and a couple where the posts would be attaching to that top step. You can also go through and look at different loads, but let's take a look at a video instead, so you can see how this is actually going to be flexing as he takes his steps, or you can see the increased stress in each stair as he walks up it, jumps, and lands on there. So that's all there is to seeing how Big Fat Hulk walks up and down the stairs, or really just up the stairs, and then jumps on the top one. Hopefully you learned a little bit of something from this, and will join me next time.